But I got to ask you about geometry, and it's a prominent topic in your new book, Shape. So for me, geometry is the thing, just like as you're saying, made me fall in love with mathematics when I was young. So being able to prove something visually just did something to my brain that it planted this hopeful seed that you can understand the world like perfectly. Maybe it's an OCD thing, but from a mathematics perspective, like humans are messy, the world is messy, biology is messy, your parents are yelling or making you do stuff, but you can cut through all that BS and truly understand the world through mathematics. And nothing like geometry did that for me. For you did not immediately fall in love with geometry. So how do you think about geometry? Why is it a special field in mathematics? And how did you fall in love with it, if you have?
Wow, you've given me like a lot to say. And certainly the experience that you describe is so typical, but there's two versions of it. One thing I say in the book is that geometry is the cilantro of math. People are not neutral about it. There's people who like you are like, the rest of it I could take or leave. But then at this one moment, it made sense. This class made sense. Why wasn't it all like that? There's other people, I can tell you, because they come and talk to me all the time, who are like, I understood all the stuff where you were trying to figure out what X was. There's some mystery. You're trying to solve it. X is a number. I figured it out. But then there was this geometry. Like, what was that? What happened that year? Like, I didn't get it. I was like lost the whole year, and I didn't understand like why we even spent the time doing that. So, but what everybody agrees on is that it's somehow different, right? There's something special about it. We're going to walk around in circles a little bit, but we'll get there. You asked me how I fell in love with math. I have a story about this. When I was a small child, I don't know, maybe like I was 6 or 7, I don't know. I'm from the 70s. I think you're from a different decade than that. But, in the 70s, we had, you had a cool wooden box around your stereo. That was the look. Everything was dark wood. And the box had a bunch of holes in it to let the sound out.
Yeah.
And the holes were in this rectangular array, a 6x8 array of holes. And I was just kind of like, zoning out in the living room as kids do, looking at this 6x8 rectangular array of holes. And if you like, just by kind of like focusing in and out, just by kind of looking at this box, looking at this rectangle, I was like, well, there's 6 rows of 8 holes each, but there's also 8 columns of 6 holes each.
Whoa.
So 8 6s and 6 8s. It's just like the dissection proofs we were just talking about, but it's the same holes. It's the same 48 holes. That's how many there are, no matter whether you count them as rows or count them as columns. And this was like unbelievable to me. Am I allowed to cuss on your podcast? I don't know if that's, are we FCC regulated? Yes. Okay. It was fucking unbelievable. Okay. That's the last time.
Get it in
This
there.
story merits it.
So 2 different perspectives on the same physical reality.
Exactly. And it's just as you say, I knew that 6 times 8 was the same as 8 times 6, right? I knew my times tables. Like I knew that that was a fact. But did I really know it until that moment? That's the question. Right? I sort of knew that the times table was symmetric, but I didn't know why that was the case until that moment. And in that moment, I could see like, oh, I didn't have to have somebody tell me that. That's information that you can just directly access. That's a really amazing moment. And as math teachers, that's something that we're really trying to bring to our students. And I was one of those who did not love the kind of Euclidean geometry 9th grade class of like, prove that an isosceles triangle has equal angles at the base, like this kind of thing. It didn't vibe with me the way that algebra and numbers did. But if you go back to that moment, from my adult perspective, looking back at what happened with that rectangle, I think that is a very geometric moment. In fact, that moment exactly encapsulates the intertwining of algebra and geometry. This algebraic fact that, well, in the instance, 8 times 6 is equal to 6 times 8, but in general, that whatever 2 numbers you have, you multiply them one way, and it's the same as if you multiply them in the other order. It attaches it to this geometric fact about a rectangle, which in some sense makes it true. So, who knows? Maybe I was always fated to be an algebraic geometer, which is what I am as a researcher.